Assalamu alaikum. We're going to be doing a review of chapter 8. And to begin, we're going to be talking about a very simple concept. This whole chapter is about quadrilaterals. Quadrilaterals are four-sided figures, and with that, you need to figure out how many degrees are inside of a polygon with four sides or any sides in that matter. So we have a formula for this. It's n minus 2 times 180. So in this case, since we're working with quadrilaterals, we're going to say this is a 4. So 4 minus 2 times 180 is going to give us 360 degrees inside any quadrilateral, four-sided polygon, no matter how it is. It could be a kite, a parallelogram, a rectangle, a square, is going to be 360 degrees. Using this formula again, however, you should be able to find out how many degrees are inside any polygon. So if I give you a triangle, you do 3 minus 2 times 180, and you could tell me that a triangle should have 180 degrees inside of it. And a five-sided figure like a pentagon, same thing, n minus 2 times 180. And so this would be this would be 5 minus 2 times 180. And I'm not sure why my pentagon went away. And so this should be, let's see, little math involved. 180 times 3 equals 540. So 540 degrees inside of a pentagon. You should be able to know how to do this with any polygon. I can give you a certain, let's say, 15 gone, and you should be able to do it. As for the names, you should know the names also. We already went over triangle, quadrilateral, pentagon. Then it's a hexagon for a six-sided figure. And then a heptagon. And then the octagon. And then we're going to go straight to 10. Decagon. And a 12-sided figure is dodecagon. Now, one other concept about this is that if you had a regular polygon, for instance, a regular, let's say, triangle, you should be able to figure out if each side are equal, how much does each side have? So you just use the same formula as before. However, you had to divide it by the number of total sides. So n, in this case, because of this triangle, you do 3 here and 3 here, and if you work it out, you get 180 divided by 3 equals 60 degrees. So each of these should be 60 degrees. And this works for anything. So since we're on the quadrilateral, let's work with a quadrilateral. We have our perfect square right here, and we're going to figure out how many would each of these sides have. So we do n minus 2 times 180 and divide by this number of sides there are. So in this case, because we're working with a quadrilateral, we're doing 4 minus 2 times 180 over 4, which is going to mean we're going to go down to 2 minus times 180, which is 360 over 4. So each side is going to have 90 degrees. So in a perfect quadrilateral like this, each side, a regular one, each side will be equal, which will be 90 degrees. The second concept you need to know is about the exterior angle. So if I had a regular polygon, and if I took one side from here, and I'm going to use a blue one, and I continued on, I'm going to have what's called exterior angles. So this angle right here is going to be exterior angles. No matter how many sides the shape has, it is always, always, always going to be 360 degrees. So if I want to find out in a regular pentagon how much each angle is, I would just have to divide it by the number of sides in that figure. But it doesn't matter if it's 6, 100, how many degrees, it's always going to be 360 degrees. So that basically covers 8.1. We'll be moving on to 8.2. And what we do here is talk about parallelograms. Parallelograms were the first and basic type of quadrilateral we talk about. So a parallelogram, let me see if we have it here. Well, we can use the time. Let's do this. Let's say this is a parallelogram. The main key factors of a parallelogram are that the sides opposite are parallel, and the sides opposite here are parallel. Now, once we know that this is a parallelogram, there are 4 things we can figure out from here. If I told you this is a parallelogram, you will know right away. In fact, let me just draw it right on here. You will know right away, the first thing as already marked, that the sides across from each other are parallel. That's of course important. But from that, you also know that they're going to be congruent to each other. So the sides across from each other are congruent to each other. So the opposite sides are congruent sides. That's one thing you know. The second thing you know is that, let's see, erase this. And I lost my parallelogram. And the second thing that you know is that the opposite angles are going to be congruent to each other. So opposite angles in a parallelogram are congruent to each other. The third thing that you know is if I were to bisect these parallelograms, go right to the middle and make a point here, this line, let me make them different colors. If I bisect it here and here at point M in the middle, then this 2 sides will be congruent and these 2 sides will be congruent to each other. And the very last thing about parallelogram is you got to think back to your parallel lines that we did back a few chapters ago, and I had a straight line here and a straight line here and a line going across from it, and I asked you what are these 2 sides right here. So 1 and 2, and you would probably tell me is consecutive interior angles, which means they're going to equal 180 degrees. Um, they equal 180 degrees. They're supplementary. That's the word I'm looking for. So it's similar in this triangle and this polygon right here, or parallelogram. Let me erase all this stuff here. If I took any of these 2 sides, so we'll call this x and y, x, y, because they're the same, we told you across from each other. If I took any x plus any y, so 2 sides right next to each other, they're going to be supplementary. There's going to be 180 degrees. That's great. But now let's go backwards, the corollary. If I'm given a figure, how do I know it's a parallelogram? Well, one of the things is if I am given this polygon, a quadrilateral, and I was asked if it's a parallelogram, one of the things that we do is if its opposite sides are congruent, then we say yes, it is a parallelogram for sure. Second thing is if I told you that the opposite angles are congruent, and it has to be both angles. If I tell you all 4 angles, so these 2 are congruent and these 2 are congruent, then yes, that is enough information for us to know it's a parallelogram. If I just told you that this is a line and I bisected it, and I told you that after I bisected it, well, they're hit right in the center, right? And they bisect each other. That is enough information. No, it is a parallelogram. So these are kind of part of the first 3 rules I went over on the last slide. And the last few things are if I told you that they are parallel, and the ones that are parallel are also equal to each other. The line's length is equal to each other. That itself is enough information. And the very last thing is very easy. If I told you that these lines are parallel to each other and these lines are parallel to each other, then that is enough information to know that is a parallelogram. So fairly easy. We move on to different types of quadrilaterals. We move on to 2 different types or 3 different types we're going to talk about. Now these all 3 are parallelograms. We're going to talk about a rhombus. We're going to talk about a rectangle, and we're going to talk about a square. So it works out beautifully right here. And so let's talk about this. What is a rhombus? A rhombus is a parallelogram. So these are all parallelograms. All 3 of these are parallelograms. But a rhombus means they're all equal sides. Does that mean they're all equal angles? No, they're all equal sides. Now a square is also all equal sides, but the difference is they're all 90 degrees angles in a square. A rectangle is also a parallelogram, but these 2 sides are equal to each other, and these 2 sides are equal to each other, and of course, all of them are 90 degrees. So in this case, by definition, a square, yes, it is a rectangle, but a rectangle does not necessarily have to be a square. So let's go into the corollaries of this. If I gave you a figure, let me erase all of these. And I think we might have to go on to part 2 for this. All right, so I'll see you in a bit. Assalamu alaikum.